Our first lesson in this unit is a review on slope and forms of lines. That's going to be super fun. All right, so let's first of all remind ourselves of the slope formula. If you recall, we've got m stands for slope. We've got y2 minus y1 over x2 minus x1. This is the ratio between the vertical change, so rise, over the horizontal change, so run, rise over run. And we can use slope in different kind of applications. We can use it to represent an average rate of change. We can also, if we are talking about a real life application, there would be units associated with it like miles per hour or degrees per day. We have a few special cases. We've got parallel lines. If you recall, parallel lines have the same slope. And then perpendicular lines have opposite reciprocal slopes. So for example, an opposite reciprocal, let's say the slope is 4. The opposite reciprocal of 4 would be negative 1/4. So that's just an example of opposite reciprocal. All right, let's talk about the different forms of lines now. So standard form would be the ax plus by equals c. And some specifics about that, or the conditions, is that the numbers a, b, and c must be integers. And a, in particular, must be positive. All right, so that's standard form. Then we've got point slope, which is my favorite, point slope form. Point slope is, y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is a point on the line. The third type is slope-intercept. A lot of people like slope-intercept form. I tell you, slope-intercept form is really good for graphing lines. It's great. It's y equals mx plus b, where m, again, is the slope, and b is actually the y-intercept. And that would be a point in the form of 0 and then b, right? Because it's the y-intercept. Y-intercept is where it crosses the y-axis, right? So that would be the y-intercept. So some exceptions would be horizontal lines. Horizontal lines are in the form of y equals, some number. And the reason being, if you take a look at a graph of a horizontal line, let's say this is our horizontal line. Okay, sorry, that's a horrible line. You can see that the y value, let's say this y value is at -2. You can see the y value is always going to be -2 no matter what. So this equation of this line would be y equals -2. A vertical line, on the other hand, the equation of the vertical line would be x equals, some number. Because if you look at the vertical line, notice the x value, let's say this is a 4. Notice the x value is the same all the time. So this equation would be x equals 4. So that's just some reminders. All right. Let's jump into, we just have a few examples to go through today on all of this. So just backing up for just a moment, we do want to talk about slope. So a horizontal line has a slope of 0, and a vertical line has a slope which is undefined. Just a reminder. Okay, so the first example, they want us to write an equation of a line which passes through -1, 2 and is parallel to the line x equals 5. Now I'm really visual, so I'm going to want to look at this. I just want to look at the graph and get my mind wrapped around what it is they're asking us to do. So here is the point -1, 2. Okay, so the line is going to go through that point, and it has to be parallel to the line x equals 5. So let's go to where x is 5. 1, 2, 3, 4, 5. And if x is always going to be 5, then this is what it would look like. Okay, so if they want us to write the equation of a line that passes through that point and parallel to the line x equals 5, then it's going to have to be another vertical line, right? I mean, that's just what it has to be. So we can tell visually that this line would be x equals -1. That would be the equation of that line. Okay. The next example wants us to write an equation in slope-intercept form. So let's remind ourselves that's y equals mx plus b for a line passing through those points, -5, -2, and -3, 8. So we need a few things. We need to know the slope. So we're going to use our formula for slope to find the slope. So for example, this we could call our x1 and y1, and this would be like our x2, y2. So the slope would be 8 minus a -2 over -3 minus a -5. And so that would give us what, 10 halves, which would be 5. So our slope is 5. Now we can't really jump right into slope-intercept form because we don't really know what b is. We don't really know what the y-intercept is. So we're going to have to kind of, get to it in a roundabout way. Instead, the easier task would be just to go ahead and plug into, yes, my favorite equation of the line, which is point slope. So let's just plug into point slope, and then let's just do some algebra. So point slope would be, and it doesn't matter which of these points you use. I'm going to use this point just because one of the numbers is positive. I would rather work with a positive number. So let's use point slope. So I'd have y minus 8 equals 5 times x minus a -3. So we know that's going to be x plus 3. So let's start working, just doing some algebra. We're going to distribute the 5. So we have 5x, and then the minus is plus. So plus 15. And then move the 8 over, which would be adding to both sides, and that would give us a 23. So there's our equation in slope-intercept form. Okay, great. The next example wants us to do standard form. So let's just remind ourselves about standard form. That's that ax plus by equals c. And so let's think about this for a second. We want the line to pass through the point -3, -5, but we want it to be perpendicular to this line. So let's see, we need to identify the slope of the line. The slope is -4, and if you recall, perpendicular slope is going to be opposite reciprocal. So the perpendicular slope would be, let's see, since that's negative, it's going to be positive. Since it's 4, that would be 1/4. You'll remember from geometry, that's just a symbol for perpendicular. Perpendicular slope is 1/4. So m is going to be 1/4. Okay, great. That's helpful. Again, we can't just jump straight into standard form, so we're going to have to use, yes, my favorite form, which is point slope. And let's use the only point that we have. So y minus a negative 5 equals, the slope is 1/4 times x minus or minus 3. Okay, so that's y plus 5 equals 1/4 x plus 3/4. So we have options. I mean, the order that you do things in many times doesn't matter. We do need to get the 5 and the 3/4, those together. Does it matter if we clear the fractions first or do? I mean, not really. But let's just go ahead and play with fractions. And so let's go ahead and move the 5 over. So we would subtract 5 from both sides. So let's just do a little scratch work out here. So we would need to do 3/4 minus 5. So that means we need a common denominator, which would be 4. So 5 times 4 is 20. So that'd be what? Negative 17/4. Well, okay. Well, that's all right. We need it to look like this. And we really can't have fractions. So I want to clear the fractions next. I would multiply the whole equation by 4 since my common denominator is 4. So that would give me 4y equals x minus, what would that be? 17. Okay, making progress. We need to have the x come first and then the y and then the number. Okay, well let's move the x over. So I've got negative x plus 4y equals negative 17. Let's see if we have satisfied everything we want. Let's remind ourselves, oh, a has to be positive. Remember that? A has to be positive. So let's finish this out. Multiply everything by a negative 1. And that gives us x minus 4y equals 17. Yay! So there's our standard form. And the last example, let's see, they want us to find the x-intercept and y-intercept of this particular graph. So let's remind ourselves, an x-intercept is where y equals 0, and a y-intercept is where x equals 0. Okay, we can do that. Let's start with the x-intercept. Let's go ahead and plug in a 0 for the y. So 0 equals negative 8x minus 4. And let's solve for x. Moving the 4 over, we get negative 8x. So x would be negative 1/2. So now we don't want to say x equals negative 1/2 per se. That could look like the equation of a line, right? Could look like that. So why don't we write it in point form? So negative 1/2 0, just so we're clear about what we're trying to communicate. For the y-intercept, we want x to be 0, so let's plug in or substitute a 0 where the x is. And so we get y is negative 4. Again, let's communicate clearly. It's really not the equation of the line y equals negative 4. It actually refers to a point. So that point would be 0, negative 4. And that concludes our lesson for today.